earliest of that was of the Greeks. One of the philosophers, Democritus, wondered, if you break a piece of matter in half, and then break it again, how many breaks will you have before you break it no further? Fast forward 2 millennia into the future, and the physicist J.J. Thomson discovers particles called electrons, which are negatively charged particles. This led him to think that they would have to be coupled with their positively charged particles, which he called protons. He then proposed an atomic model for these atoms that he thought looked like raisins stuck on the surface of a lump of pudding, where the electrons represent the raisins, surrounded by a body of positive mass. Hence, the plum pudding model was born. Leave it to Ernest Rutherford to prove Thomson's plum pudding model wrong. In 1911, Rutherford, along with scientists Hans Geiger and Ernest Marsden, set up an experiment. Rutherford first observed that when positively charged alpha particles with high energy were shot at high speed into a piece of thin gold foil, most of them would pass through the foil. In this experiment, now coined the gold foil experiment or the Geiger-Marsden experiment, they found that while most of the alpha particles passed straight through the foil, some of the particles were deflected by the foil at very large angles of up to 180 degrees. Using Thomson's model, Rutherford could not explain what happened during his experiment, so he proposed a new model regarding the structure of the atom. He suggested that the positive charge of the atom was concentrated in a small area in the center of the atom, with electrons orbiting around it. After numerous tests, he concluded that the diameter of the nucleus was much smaller than that of the atom, 10 to the 5th time smaller to be precise. It is at this point we are approaching the atomic model we accept today, but there's more because even Rutherford's model has been proven obsolete. In comes Niels Bohr, who modified Rutherford's model by applying it to the theory of quantum mechanics. For Bohr, electrons travel in random motions in accordance with their quantums, or energy levels, which are fixed for each atom. Bohr crucially noted that an electron can travel at one quantum or another quantum, but not in between. Combining these models together, we find ourselves where we are today, with a widely accepted idea of the atom, the Bohr-Rutherford model. This model has electrons in random motions at fixed orbitals around the nucleus, which is comprised of protons and neutrons. Protons are positively charged, electrons are negatively charged, and neutrons have no charge. Combinations of these subatomic particles comprise each and every one of the elements we know today, which comprise all the matter in the universe. Isn't that cool?
But wait a second, we can't end this presentation without qualifying everything we've just said.
Just as Democritus's ideas were disproven by Thomson, whose ideas were disproven by Rutherford, whose ideas were modified by Bohr, science today is still in the process of constant re-evaluation.
Technology is still limited, such that we have never yet seen an actual atom. All of these atomic models are just theories, and none have been conclusively proven. Who knows what the physics students of the future will study, and whether they will see our models of today the same way that we see the models of yesterday.
This presentation may be coming to an end, but the eternal search for scientific knowledge will live on forever. Long live science, and long live the atomic model.